somewhere around beyond 12 years back, I developed an energy slideshow because I thought it would be particularly important to our country and our society.
Could you hold the mic closer to your mouth?
All right. And, you know, I used to live on an old farm not too far, and I put up my first solar system on our barn, and then went ahead with a lot of issue putting up additionally a wind turbine system. So I sort of feel as though I have a little bit of background in actually doing some of this stuff and living with it. I can see right away one of the issues is going to be is this science stuff for real or not? And well, let me just tell you a little bit about my own approach. One of my favorite physicists is Richard Feynman, and he's the fellow who did electrons in light. And he comes from Brooklyn as I do, so I feel a certain kinship with him. But one of the things I heard him say once is that in physics, when we talk about a law, such as the law of gravity, the law of the conservation of energy, you have to understand what law means. It's not like God handed that down in a tablet on a mountain somewhere. It's what the science of physics has hypothesized and decided works when we try it out. But it doesn't mean we should hold it rigidly in mind and think that this isn't potentially going to change when somebody else comes along with another thought and idea. And what I like to do is put myself in this TV show called Who Wants to Be a Millionaire, where you get given a bunch of questions that you have no idea what the answer might be, and you have some of your help in gaining this $1 million, an audience who can give you advice if you ask for it. And put myself in a spot where I could really use this $1 million at this point in time. I have some key issues in my life, and they would those $1 million solve a lot of problem for me. And here I am given a question. To me, is absolutely ridiculous. I got no idea whether the answer is A, B, C, or D. And so I go to the audience, and the audience pushes this little button, each individual there, and I come back with an answer. 97% of the audience says the answer is C. And what I say to myself is, let's look at the audience. How do they pick the people who are answering this question? They're probably from a large outside population, people who want to see the show. And then I said to myself, well, let's put together a group of earth scientists and fill the audience with them. These are people who have PhDs in the subject. And it's not that they just have PhDs, they're people who are working in the field every day. That's their work. They have their hands in the soil, so to speak. And let's ask them whether this change in climate is for real. And then ask yourself, if they say the answer is C, are you going to accept that? For me, with that background, I find myself accepting it with the thought that, yeah, philosophically, we could all be wrong. You know, there's a small chance, but I got to put one foot in front of the other And if I have to do that, my choice is going to be with this audience, 79, 97% PhDs in the subject they're going to tell me. Well, last fall, October 2017, I stumbled on a program that Al Gore gives, and it was in Pittsburgh, and he gives this really globally now. He's been to several cities in this country, and he's gone to Mexico City, Berlin, I think perhaps the Philippines. And for us, we had an audience of 1,400 people. We were there for 3 days. Gore was on the stage full time. And we were sent from that session with a job to do, and that is to let the public know what this looks like to people who've looked at it. And so here we are. What brings me to a senior center is, well, I'm something of an older fart here, and what bothers me is the legacy that I have to give. And I'm thinking to myself, well, the senior population perhaps is thinking likewise. As older folks, we can still do stuff. And if it only matters that we pick up the phone and talk to our local representatives, that we can do. If we can get much more actively involved, we're capable of doing it. And the idea is I'd like to send you out from here, not with the thought that you sat for this silly sideshow, but you're going to do something about it. So let me start showing Gore's show here. This is his 10-minute slideshow, and Gore does it in 10 minutes, and I'm sorry I can't do that. But let's start with a picture of where we live. We don't live anywhere else. And the idea is, with what's happening with climate change, we're starting to disrupt this in a very major way. Here's a slide that indicates that our energy comes from the sun. It comes to the earth. Some of it is reflected back from the atmosphere, some from the surface of the earth. Some of that energy is taken up by what was in the earth and re-emitted at a different frequency in the infrared, sent back up. And then some of that is sent back down to us. And that keeps the planet warm. If we looked at the energy coming in from the sun and plugged it into formulas, we would find that with that system alone, we would be very cold. And what keeps us comfortable is this system that re-emits infrared, settles in the atmosphere for a bit, some of it back out into space, some of it back to the surface of the earth, and that return is what keeps our temperature comfortable for us as human beings. None of this is meant to be jocular, but here we have what to me is an illustration in a strange way of our current conundrum. This little character, to me, represents the fossil fuel industry. And the guy in a pot here represent us folks who are living with what we agreed to have these folks delivered to us. We're sitting in a pot that is getting warmer and warmer as time goes by. This this turns out to be an issue in part of money and greed. And there's an industry out there that we've definitely enjoyed. It's been the basis for our industrial revolution. We're comfortable with it, and we're sitting here kind of warm, toasty, and happy. But yet they've tied us to their own track. We're stuck with what they've given us unless we change. Now, that little triangle that we passed around is shaped in the shape of a triangle, and mathematically, that delta means difference between or change between. And the idea is, we'd like to illustrate here, we need to change. The other thing that is that's the Cowboys' call to come get your food, cowboys, from the chuck wagon. And agriculture is a key part of what's happening here to our climate. This is one of the slides I poked in, but it sort of illustrates, again, this is climate change that's coming down on us. It stems from the fossil fuel industry here, and that's us stuck on those tracks. The us here stands dual purpose in naming this situation. Us means you and me, and us also means U.S., our country. And we're stuck unless we change with climate change doing some bad things to us. Now this is from the space station. It's a picture of the Earth's atmosphere. That's why the onions, the skin on those onions is very thin. And the same here with our atmosphere. People tend not to realize that. But if you travel vertically up at highway speeds for an hour, you're out of this atmosphere. And that's what keeps us comfortable. That's what lets us live here. The idea is we need to take care of it. It's just a slide on the carbon cycle. We'll pass that at this point. But what we're doing here is putting this stuff into the atmosphere. This is pollution in the form of carbon dioxide and other greenhouse gases. And they reflect more energy back to us. And they're warming us and warming us and warming us. And it's very hard to get us to recognize that. But I like this slide in particular because behind here you can see the rest of the train. And it reminded me of the trains we used to see occasionally out west. But there are trains that come from coal country in Wyoming and travel to the utilities in the Midwest. They're a mile long, and they have coal in every one of those cars. And that utility uses 2 of those trains in a day. That's what's been responsible for East Coast acid rain and for the mercury in the Great Lakes. That's been made better, but it's continuing to be a challenge for us to deal with. This is just a description of how this warming occurs. The greenhouse gases basically put a blanket over us here. and sit there in that atmosphere. One of the things I found talking to basically a high school teacher, the principal the other day, was the thought of what happens to carbon dioxide in particular when it sits here. And he thought, well, it just gets reabsorbed by the plants and it then contributes to the plant's growth. Doesn't stay there. That doesn't turn out to be the case. The CO2 is there for a long, long time. And this shows that. It's there here for many years. And to some degree, in the thousands of years. So that once we put it there, it's god-awful difficult to get rid of it. This is where those gases get made. It shows where some of our industry exists. So we use about, depending on whose numbers you take, a third of our energy for transportation, a third of it in our buildings, and another third of it in our industry. One of the things that's become particularly concerning to me of late is what this does to agriculture, and in particular also here what it does to the permafrost. The permafrost is the frozen land above the Arctic Circle, which because of warming now is defrosting. And it's leaving us with a higher concentration of methane. Now, methane is also a greenhouse gas, doesn't last in the atmosphere quite as long as CO2, but it's much more potent as a greenhouse gas, meaning it sends much more radiation back down to the Earth's surface to warm us up. That's a frightening thing, and if you've seen some of the pictures of Siberia lately, you can recognize that. If I can get this to move on. Since about the end of World War II, 1945, we've enjoyed the use of fossil fuels. It's been the basis for the Industrial Revolution. But wow, have we started using them in a big way. And that's had some effects for us. Again, since about 1945 or so, the temperature has risen. I gotta just find the right button to push here. Now, these slides come from the 2017 session in Pittsburgh, so that's a 2016 number. It's old now. This is a picture of Trinity Church in Copley Square here in Boston. And it's of an individual who's gotten into difficulty with high temperature. And this can be a malignant issue. Heat waves send people to their deaths, really. And, well, how many? In 2003, it turns out that in Europe, something like 35,000 people died because the temperature was too high. That's a lot. It happens in sporadic locations, and we don't always hear about it. But it's been there in Russia and in the Middle East, and I think Japan has recently had an experience like that. Where does this heat also go. It goes into the ocean. And today, while driving here on public radio, there was a notice that the anticipated heating in the oceans has gone 40% beyond the expected heating in that ocean. Today, the Boston Globe has a similar article. That's where a lot of it goes. What happens with that? Here's a picture of 3 hurricanes at the same time in the ocean in 2015. How does this happen? The ocean gets warm. The surface of the water is warm. That warms the air at that juncture. That air holds more water vapor. The heat in that ocean allows for more water vapor in the atmosphere. And it does things like these atmospheric rivers. But it makes for clouds. The clouds come over here and give us rain. The rain falls, goes into streams and rivers and ponds and comes back to the ocean. But what we get here is rains like this. This is a picture of what's called the rain bomb. But globally, we see a bunch of these. This is a picture of India. This is the short presentation of Gore's slides. In his longer presentation, he's got gazillions of pictures of floods globally, pictures like this. We all remember Houston, but here in Boston, we're a good distance from Houston, and we don't always see it. We did last winter on the Seaport District. We were overwhelmed with water, but this is happening. Here we see that the ocean evaporates water from its surface, but that same thing happens to the water in the soil, and we lose water there, and we wind up with droughts. What we end up with here is a situation where we got to ask ourselves, how are we supposed to grow food in that? If anybody has been to California of late, we know that this is a huge issue. And it doesn't seem as though we're going to solve it by raking our forests. This is a picture of Fort McMurray in Alberta. And Alberta is the place where tar sands oil are recovered. It's a big industry up there, and boy, do they devastate that landslide. But this is a forest fire, and why that oil didn't catch fire is absolutely beyond me. But they had to evacuate that whole outfit, something like 100,000 people. It's a problem. It's not just the fires. We got droughts, floods. When the fires take the vegetation away, the land, the soil itself is no longer stable when it gets rained on, and we end up with some significant mudslide problems. And we got more and more severe storms. Spot on the screen for this. This is Florida, Miami. This happens when the tide comes in and it's a high tide. This is posh Miami Beach. My daughter lives down that way. There are fish in this water. Sorry. I have to try and retrieve that. This slide, I try and go back here, is meant to indicate what that rising sea level does to us in terms of losing our assets. This is wealth which is going to be lost when that water comes up the way it does. And number one on the list here for us is Miami, and then across the globe it goes down. We find New York and Newark here. But when we look at it from another perspective, how many people lose the place in which they live and work? And look at what happens to Miami. It's way down here. But look at what happens to Calcutta. And look at the volume of people who live there. And look at how much is lost to those folks in the way of their homes and businesses and lives. This is from our Department of Defense. What I remember is Obama going to the graduating class at West Point and telling those new soldiers that their biggest challenge in their careers in the Army is going to amount to dealing with climate change. One of the issues is going to be from refugees that have to leave where the climate has made their geography unlivable. And already the UN has decided to deal with this. Is there a picture of their meeting in Marrakesh, December 2018. But they're looking for safe, orderly, and regular migration. And I dare say it's hardly been that. We're not entirely welcoming of all these migrants. Now, food is an issue in particular here because they like to be warm, but they don't like to be hot. And food plants won't tolerate excessive temperatures. This is a study that comes from the School of Public Health. When the atmospheric carbon dioxide increases, in theory, plants have a better opportunity to grow. And in theory, we get a lot more plant life with higher carbon dioxide in the atmosphere. But when we look at what those plants are supposed to do, a good part of that is to provide for us our food. And it turns out that when the CO2 rises, the plants are able to function as producing what we look to as food as well. So that plant mineral content and protein levels tends to be much lower, significantly lower. And in a study, the School of Public Health finds itself worried about malnutrition, in particular from places like India. These are the foods that those folks tend to eat frequently, and that seems to be what's threatened. When the temperature gets hotter, the insects like it better, and they tend to nail our food. Those of us who like coffee, here we got a fungus on the coffee plant that's there because it lives better in a higher temperature. When it sits there on a leaf, it can ruin the coffee plant. Even those of us who enjoy our beer, in the state of Washington, the local beer brewers have a favorite hops, and the growth of this hops is threatened by the water supply, and those folks have been worried about whether or not they have enough water to provide a good product. This is a medical issue. Around warmer climates tends to be this whole long list of diseases. What Gore likes to point out in particular is the Zika. The Zika went into Miami. Last season they were running around Miami spraying because potentially they lose all their tourism. And all those people who went down there to buy their vacation homes and live there in the sun on the beach wondered whether they were doing the right thing. In Brazil, it turns out that there were something in the way of 5,000 to 6,000 babies born infected with Zika. Now, these are kids with half a head, half a brain, and they can perhaps sit there in a crib in diapers where they pee and poop, and they can cry for food and can suckle for food. But that's it. And what are we supposed to do with those folks? Do we care for them that way for a lifetime? It's a huge philosophical problem where I'm concerned. But this is the mosquito that carries that virus in higher temperatures, in higher climates, in higher latitudes. This thing has a wider range. It's got more time to fly around. The virus has more time to multiply. We're also losing a great deal of our species. This is a frog that no longer exists because he could only live in a narrow range of temperatures. And so you could say, well, am I going to miss that frog? And maybe not. But there was an episode a while back where someone picked up that there was a rodent who had no hair, was bare-skinned. And it turned out somehow that particular rodent never got a cancer, where the others of that same species did. And I said to myself, wouldn't it be interesting to be able to have that critter around to be able to try and figure out why and whether we can apply that. Same thing over bats. If bats get lost, they take up and eat an incredible volume of insects. And we all remember the biblical plague. This slide is meant to indicate that when we go to the gas station and fill our car with gas or home fuel oil, that bill that we see doesn't list the entire cost of what you're buying. There are a whole list of peripheral costs that we get stuck paying for because we use that particular fossil fuel entity. And some of them are listed here. In the wildfires in California, we're going to be stuck helping those people out financially. Same with floods and mudslides. Drought, we got to help the farmers out with their flood, with their insurance plans. When Hurricane Sandy came through, we sort of saw it nearby. We had to repair a whole huge segment of the subway in New York City. In acidifying the ocean, I have a grandson who's down in Florida, and one of the things he's done is do transplants there to the coral. But in the coral is the fish, and the fish ends up being our food. It goes on. So what are we supposed to do about it? Are we stuck here? Are we stuck in that pot in one of those first slides? Or is there something to happen? Here he wants to indicate that the initial projections when the century turned were far exceeded, meaning not only can we do it, it was done. From the wind as an energy source, there's a lot of capacity there. There's enough to take care of us. All we got to do is go out and capture it. That, believe me, can be an issue sometimes. But it's important. Again, the early projection was exceeded. It's growing. May not see it all the time here, but globally, it's possible, and it is working. This is sort of an interesting slide. The costs have come down as manufacturing improves quite a bit. We can use solar in all sorts of different places. Here's it's a single module, and what it does is put power in a battery that the kids in that hut can use at night to turn on the light to do their homework. Look at what they do in other countries. For those of you who would really like to see what that looks like, holler at me afterwards. I've got some slides on what the people in Chile have done. It's incredible. But you can do it. You don't have to say, here, well, what are we supposed to do? One of the issues with both wind and solar is that those energy sources tend to be intermittent. The sun doesn't always shine. The wind isn't always blowing. He can look at that being aided with the combination, meaning when there's a storm, there's wind, no sun. When at night there's no sun, potentially you have wind. But ideally, you need storage to cover those times when you have none of those two sources available. So storage forms of battery becomes important. It's a blooming industry in this country, in the globe. It will be and is important. Efficiency and how we use our energy is clearly an issue, and it's in a large degree solved as the example of LED lights. Use a lot less energy, come up with the same endpoint. Here, Gore lists all those folks that are moving to build electric vehicles. My answer would be, yeah, but be careful, because you got to power those batteries, you got to power those fuel cells. And if you don't do it with a renewable source, you're still doing it with something that's going to put greenhouse gases in the atmosphere. This is an example of how not to do it. We've had here in the state a small trial of these electric school buses. They were made in Canada, went seemingly to small school districts. The people in Canada gave the local maintenance people some bit of training, but it seemed as though largely there was one individual, maybe two, in the repair shop that knew what was happening with these when they ran afoul of function. And it didn't work all that well. It turned out that when they compared to what happens in terms of greenhouse gas emissions, it was better. But it was done poorly, and I'm not sure they're going to continue to use those that way. But when this gets started, it needs to be done right, is all I mean to say. If you look at these slides, they indicate that China, in particular, is looking to use electric vehicles in a much bigger way. What's the matter with us? Gore was a big part of this Paris Agreement. And everybody is signed to it. Syria, North Korea, everybody now but us. It turns out we can't actually get out of it until the day after the 2020 election. Gore suggests we do things like this. And he says, if you look down here, that's him. This is where we are. We got to handle this properly. These are his books. In particular, the first one, a friend of the family mailed this book to me the other day, and that came out in '05. As soon as it came out, I read it, and I hadn't reviewed it since it initially came out. And here it is. The other night I went through it again. It's worth going to the library, picking up, and getting a picture better what's really happening. His other long slideshow shows it much better. If anybody's interested in seeing that, I'm available. I'm happy to show it to you. If you bring some mid-show tea and cookies, we'll be fine. This slide is where CO2 tends to be monitored from the atmosphere. They do that in Hawaii, and you can see it's still climbing. It's too high. It's just a slide to indicate that this ocean current, which tends to keep places like England, Europe, warmer than otherwise they would be, is now having a 15% fall in its flow. This means to indicate here that we got a problem, but it doesn't mean that we're going to fall apart because there's nothing else to do. We can't let denial here that something is happening be unrecognized, and we can't let that fall into despair and end up doing nothing. Let me just, in this part of it here, what I'd really like to do is show you a bit of what makes me come to this session. Take me a little while to get this thing warmed up, but I hope to give you another perspective. That's what brings me here. That's the next thing that brings me here. That's what's going to happen if I'm not effective in doing something. That's my grave. That's my kids and grandkids. And that's what's going to happen if I stand here knowing something is about to come down on us and I don't at least try and do something about it. That's the same picture. That's where we live. We don't go anywhere else. It's the same thin atmosphere picture. If I get rid of this thing. Again, the idea is we sort of think that we can throw all this stuff into that atmosphere and get away with it because that spot ends up being a limitless dump. And it isn't limitless. It's one set of pictures that really gets to us. Some long while ago, they sent out a robotics spacecraft. I think they called it the Vanguard. And they sent that to a point where it was 4 billion miles beyond the solar system. Not just the planet, but the solar system. Recognize it's quite a distance. And Carl Sagan was the guy there who said to NASA, you boys, how about turning that camera around and see if we can see where we live. And that's the picture they got. That's us. And if you listen to that astrophysicist Stephen Hawking, one of the things I heard him say once is one of the most important things astrophysicists can do is now find a place where we can go out into the universe and live, because this place where we now are is no longer tolerable. The sun is going to fail at some point, but the way this climate is changing, you have to understand it's happening fast and quickly, and you have to pay attention to it. Because once you travel this 4 billion miles and find out there's nothing else we can live in that little spaceship, you can't turn around and say to your honey in the next seat, you know, God, I'm getting a little hungry. And how about we pick out a 7-Eleven and pick out a Coke and a sub? It ain't there. This is where we are for the time being and the number of generations we hope. This is another deep-seated philosophical problem that I'm sorry we got to deal with. I don't know how to deal with it, but we gotta. And the year 1900, our population on this planet was somewhere around 1 billion, maybe 1.5 billion. When the year 2000 comes by, next century turns, we got 6.5 to 7 billion more people. So the population grew 6.5 to 7 times in that period. Also, look at which population grows. They're third world countries. They're countries who, with the internet now in particular, are seeing what the guys in the blue here are living like. They want the same bells and whistles. They want the same energy sources, the same comforts, the same food level, on and on. Can't blame them. But what are we going to deal with this? There's another slide that essentially shows the same thing. Go from a billion people, maybe a little more, to 6.5 to 7 billion, right about here. So until I saw these slides, I really hadn't recognized that we're going to have to deal with it. And again, it's shown in blue here, it's the developing world. People are going to be clamoring for our bells and whistles. This is a slide to remind us where our energy comes from. Well, our energy supplies our greenhouse atmospheric gases, so that's why we got to pay attention to it. These numbers here should read 1,600. But you see, initially in our history, we've used wood. And then in the mid-1800s, we found coal, in particular in England, and then oil, and with oil, natural gas. And then we built the Hoover Dam. The Swiss used hydropower. And in 1957, here, we built the first nuclear reactor for our electric power. But something is missing. I wonder if anybody can figure why or what. No, it's this. Who are the individuals who took this mountain and carved this building in Petra? There's a bunch of people. And the people who are helped with these critters, they're called animals. And because we don't believe in slavery anymore, we don't really do that. But when you look at Egypt and these pyramids, I begin to recognize that they had entire cities with the guys who constructed these pyramids. They had to have somebody every day to sharpen their initially copper chisels. The copper was a poor chisel. It needed resharpening very often. And there had to be a guy there all day long just sharpening copper chisels. But they had to provide food and clothes and shelter and rest and water for a large community. And, animals, people, we don't use them that way anymore. What happens when we use our resources in the wrong way? This comes from Gore's first book. This slide depicts it poorly, but this is a continuum. In Haiti, the dictator decided he would take all the rich tropical wood down, sell it at a high price in Europe where the demand existed. This land is no longer arable, doesn't hold soil. They happen not to have any resources, no oil, coal, gas, diamonds, copper. And with that situation, it's hard to say, come here and enjoy our landscape. In the same island, just a technical border away, is the Dominican Republic. If you take a tree down there, you better have a permit for it, or they come after you. And I think you spend some time in the Huskow. It's nice enough so that they have a tourist business there. You got to pay attention to what we do. One of the problems here has been inertia in terms of doing things. If anybody's interested, I have a lecture that Admiral Hyman Rickover gave in 1957 to the Minnesota Medical Society. And he talked that we have to be very mindful of what we do with our Earth's resources. We have to take care of our planet. And it turns out for over half a century now, we've done nothing with an argument that makes a tremendous amount of sense that says we should have done a lot. This is a neat book. If somebody's looking for something to try and go to sleep at night, pick it up. It's written by a couple of cyber people, Clark and Eddie. And Clark talks about the theme of this book, and it amounts to the Cassandra story. What we're afraid of. It's just this, that with what we're looking to, with what this climate is going to do to us if we don't do something, we're not going to have the same type of civilization that we have now. It's going to happen fairly quick. This is Cassandra. She is the princess, the king and queen here in the city of Troy, which is somewhere, I think, in Turkey now. She loved that city. That was her favorite spot. She loved the people. She loved the structure of Troy. And it turns out that Apollo took a gander here and said, I want you to be my gal. And she said to him, get lost. And he said, well, how about I give you the gift of prophecy. You can foretell and foresee the future. And she sort of said, well, okay. And he said, all right, you're my gal now. And then she said, nah, that doesn't go for me. He got upset, and he said, well, you still have the same prophecy, but when you see a tragedy about to happen, you're not going to be able to convey that to anybody. You're the only one who's going to be able to understand that bad news is on the way. And here's Troy. You all remember the story with the wooden horse and the soldiers hiding in that and sneaking into the city when the city decided they would accept the horse. They got out of the horse, opened the gates, and the opposition army wandered in. Money is a key issue. The fossil fuel industry is supposed to have somewhere around $23 trillion worth of stock, not paper stock, but assets in the ground in the way of fossil fuels. They lose that if they can't use it. This climate is going to get worse. And we're going to have to say to those folks, I'm sorry, but we can't do this anymore, whether it's our choice or it's forced upon us because we can't live this way anymore. They're going to lose that. They don't want that. Greed is something else. It's something I have trouble understanding, but people just want more and more wealth, whether the money is coming out of their ears or not. In terms of why we're here, this is Ponce de Leon. He's here looking for the fountain of youth. Well, guess what? He didn't find it, and we're not going to find it. The only fountain of youth that we have is our next generation, our youngsters. And we kind of owe making this a good bit better for them. Religion, where this plays a role here, beware, the Pope has written a big encyclical. Take a look at it. It's interesting, just a gander, how much detail he put into writing that encyclical. He wants us to take care of the earth. This is just to remind us where we use our energy. About a third is in transportation, a third in buildings, and a third in industry. Agriculture is part of industry. Agriculture represents our food. And there have been moves of late, particularly somehow in England, for populations to become vegans. I'm not sure I know about that in terms of trying to be a voice there. But they've looked at what protein from livestock does to us. It results in a lot of greenhouse gas. You wouldn't think so, but they see that from their satellite pictures. Anybody wants to look into it more, I can show them something to read. This is my thought of what we need to look at. We need to get together and do some work here. That should be about it here. Questions? Yeah, I gave this sort of similar session at the senior center in Needham, and they got angry at me and said, you presented this as a problem to us, and you never told us what the heck to do about it. We sort of sit here going, blah, 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 what are we supposed to do now? So, I went back to them, and there's a whole nother slideshow about what to do about it. And I went over it again last night, and it turns out it's among the bigger of the slideshows I have. So anybody wants to look at that, be glad to show it. Locally in the state, we passed up last session a good bit of carbon legislation. Pick up the phone and talk to your legislators, and for God's sake, go out and vote. There is locally an outfit called 350.org. It's Bill McKibben's program. 350 is the desired atmospheric parts per million CO2 number that we're supposed to be shooting for, where it's now 411. But they meet in Sherburne and Newton and in Jamaica Plain and Boston, and perhaps even more local. Sherburne isn't far away, and it'll give you folks something to be involved in if you're wanting to be involved.